The vast universe challenges humanity with questions that go beyond just its structure and origins, but also about their evolution and the incredibly complex interactions between them. Galaxies come in many different shapes, but most of them have an elliptical disk structure. Why is that, instead of being spherical like other planets? A galaxy is a vast system of celestial bodies and matter bound together by gravity, including stars, stellar remnants, the interstellar gas medium, cosmic dust, and dark matter. An important component, yet one that has not been thoroughly studied and understood to date. Galaxies possess a wide range of characteristics, from dwarf galaxies containing a few 100 million stars to giant galaxies with hundreds of trillions of stars. Every star orbits the center of the galaxy that contains it. In most people's minds, galaxies typically have a spiral disk-like shape. However, beyond the vast universe, galaxies also come in many different shapes. For example, Galaxy PKS 201455 has a shape that looks exactly like two boomerangs spinning end-to-end. The Galaxy ESO 953 IG008 has a shape resembling a hummingbird, yet it has been bestowed with the beautiful name of the Tinkerbell Fairy. The Galaxy NGC 6240 has a shape resembling a giant jellyfish. And there are also many other galaxies with unique shapes. In 1926, the renowned astronomer Edwin Hubble proposed a comprehensive galaxy classification system, known as the Hubble sequence. Based on the differences in the optical shape and size of the galaxy images on the photographic plates, he classified the world into four main groups. Spirogalaxy, the spiral galaxy. According to 2010 statistics from the Hubble Space Telescope project, this type of galaxy accounts for approximately 72% of the total number of galaxies observed by researchers. They have a characteristic spiral shape, composed of a flat disk containing stars, cosmic dust, and interstellar gas. They orbit around a central bulge, where older, dimmer stars are concentrated. This region is believed to be the location of a supermassive black hole. The disks of the stars orbit around the bulge, separate from the arms that surround the galaxy. These spiral arms contain vast amounts of gas, dust, and young stars that shine brilliantly before quickly burning out. Additionally, this bulge is also surrounded by a galactic halo, composed of older and fainter stars, which extends through several star clusters. Science still cannot fully explain how spiral arms form and are maintained. These galaxies have a very unique way of rotating. Everything within them spins at the same speed. Therefore, the time required to complete a full rotation will gradually increase with the distance from the center. This very thing caused all the disturbances in the rotating disk, transforming them into a spiral form. And if this were the sole mechanism for forming spiral arms, we would observe galaxies with many tightly wound spiral branches. However, most spiral galaxies have between 2 and 4 main arms. According to scientists, this spiral structure is also influenced by density waves. They propagate throughout the galactic disk, causing stars and gas to pile up at the wave crests. Our galaxy, the Milky Way, has a structure consisting of 6 spiral arms. The 4 main branches are the Centaurus scutum, Perseus, Norma, and Carina Sagittarius arms. A smaller branch of it is the Orion Cygnus arm. Outside lies the Monoceros ring, a structure of gas and stars torn from and drawn in by other galaxies billions of years ago. The solar system is located about 27,000 light-years from the galactic center, in the inner part of the Orion arm. Elliptical galaxy, Tricogalaxy, elliptical galaxy. Elliptical galaxies are the most common type in the universe. They are spherical or oblate in shape. Elliptical galaxies are not very active because they do not contain much gas and cosmic dust, the essential components needed to form new stars. Therefore, elliptical galaxies are primarily composed of old, low-mass stars, so they are not as bright as other types of galaxies. Elliptical galaxies typically contain less gas and dust compared to spiral galaxies. This means that fewer new stars are being born, while the majority of existing stars are now old and tend to emit more red light. This galaxy system is brighter in the central region, where the stellar density is higher and a supermassive black hole may reside. According to predictions, It is the gravitational force from this black hole that provides the necessary binding force to keep the elliptical galaxies tightly bound together in a system. Regarding estimated numbers, elliptical galaxies account for approximately 1/3 of all known galaxies and between 10 to 27% of the galaxies in the Virgo supercluster. A galaxy cluster densely concentrated within the local galaxy group. Within the Milky Way and the Andromeda Galaxy, one of our closest neighbors exists. A lenticular galaxy is a type of galaxy with a shape resembling that of a lens. Lenticular galaxies typically have a lens-like shape, possessing intermediate characteristics between elliptical and spiral galaxies. A lenticular galaxy typically features a large central region, which is nearly spherical in shape, primarily contains old stars, and is surrounded by a disk of gas and young stars. They are shaped like a lens. A lenticular galaxy also has a disk containing gas and stars similar to a spiral galaxy, but it lacks the spiral arms. Young stars and the nebulae where they form shine brilliantly and are filled with cosmic dust. The formation of lenticular galaxies is still not fully understood. One hypothesis suggests that lenticular galaxies were originally spiral galaxies that were subsequently flattened and used up nearly all of their interstellar gas and dust. In reality, these types of galaxies can no longer produce significant numbers of new stars, as they have exhausted both the material and the necessary conditions for star formation. Consequently, they are primarily composed of old stars, similar to elliptical galaxies. Another notable hypothesis suggests that lenticular galaxies are formed when two spiral galaxies collide and merge. An irregular galaxy, also known as an anomalous galaxy. They are meteorites that do not fit into any other group in Huber's classification scheme, due to their unusual shape, size, or composition. Peculiar galaxies are believed to form from the merger of two or more galaxies under the continuous interacting force of gravity. This is also why many irregular galaxies are also referred to as interacting galaxies. With its highly unusual shape, high star formation rate, and possession of more than one active central nucleus. One of the most famous unusual galaxies is the Antennae Galaxy. They are interacting with each other in the Covers star cluster and are expected to fully merge in about 400 million years. Why do most galaxies have a flat, disc-like shape instead of a spherical one? The shape of a galaxy is determined by the state of matter within it. The matter here is not only those twinkling stars, but also includes dust, gas, and dark matter. Theoretically, young galaxies form from a chaotic cloud of dust and gas. At this stage, they do not yet have a disk shape. Over time, gas and dust can accumulate in large quantities over an extended period. Their momenta will cancel each other out along the direction of motion. But the momentum gained is still conserved, while gravity pulls everything toward the center of mass of the young galaxy. This means that when gas and dust collapse together toward the center, they cause the galaxy to become smaller after losing energy due to friction and radiation. Meanwhile, the gas and dust in the outer part rotated even faster. The faster it spins, the greater the centrifugal force becomes, causing it to gradually flatten and form a disk. Simply put, it's also due to the conservation of angular momentum, as the initial sphere it forms contracts and gradually becomes denser. Any object outside the plane of the disk can be affected or pulled toward the objects within the disk, eventually joining them to form a flat, disk-shaped structure. Disk galaxies tend to contain a lot of gas and dust. It is for this very reason that they have a disk shape. Based on the available data, globular galaxies with long-term stability are typically small and have sparse stellar density. Its matter is distributed over such a wide area that it cannot coalesce into a smaller sphere, and instead gradually transforms into a disk-like shape. Therefore, over time, the number of remaining globular galaxies is very small and they are also rarely discovered. Among the 500 billion galaxies in the universe, NASA's telescope has captured truly remarkable images of several galaxies. This is the laydown 74,886 galaxy, located approximately 70 million light-years away from us. They have a rather unique shape, looking almost like a rectangle. Although most galaxies around us are shaped like a disk, a three-dimensional ellipse, or an irregular cloud. Scientists speculate that the unusual shape of this galaxy, laydown 74,886, was formed by a collision between two spiral galaxies. But no one knows when that phenomenon occurs, and there has yet to be any official, clear, and scientifically convincing explanation provided. NGC 6872 is a giant spiral galaxy, also known as the Condor Galaxy. This galaxy is located 21 million light-years from Earth and was discovered by British astronomer John Herschel in 1835. NGC 6872 has a diameter of 522,000 light-years, making it 5 times the size of our Milky Way galaxy. The Triangulum Galaxy is one of the smallest galaxies, with a stellar population of only about 1,000 stars. However, the motion of these stars is extremely fast, equivalent to the speed of stars in other galaxies. According to Sputnik News, scientists hypothesize that this galaxy may contain a large amount of dark matter. Meanwhile, another hypothesis suggests that the cause is the gravitational pull from neighboring galaxies, including the Milky Way. Taina is the most ancient and faintest galaxy ever discovered by humanity. Researchers believe that it formed only about 400 million years after the Big Bang. The firstborn, the Hercules galaxy, is particularly notable because it contains a supermassive black hole, approximately 2.5 billion times the mass of the Sun. This black hole is 1,000 times larger than the one at the center of our Milky Way galaxy. It also emits 2 plasma jets with wavelengths extending up to 1.5 million light-years, forming one of the largest sources of radio waves in the universe. In the vast and immense universe, galaxies have always been fascinating mysteries to humanity. Each galaxy is a diverse collection of planets, stars, and immense cosmic matter, creating a spectacle that is both mysterious and utterly captivating. These cosmic dust clouds may appear serene, but they are in fact incredibly dynamic regions of space, where processes of formation, collapse, and renewal are perpetually at play.